All right, welcome to our next video about the notation we're going to use a lot, Rn. We're going to talk about this notation and what it means a little bit and just describe some of the language we use to describe points in higher dimensional geometry. So Rn, so first of all, there's just the R with the extra line through it. That just stands for the set of real numbers, but then the power n means you have more than one coordinates. So this means the set of all points with n real number coordinates. So for example, R1 is usually just called the set of real numbers, is just the set of real numbers. And R2, you've worked with a lot, is the set of all ordered pairs. And R3 stands for the set of all X, Y, Z ordered triples. And you could use, when you're describing sets like this, you could use English like this, or we could also use set builder notation, mentioned in the last video, where you write this as like X, Y, Z, the set of all things of this form, with a vertical line that means such that, and then just write that X such that X, Y, and Z are real numbers, and you can just say that they're in R as a shorthand way of saying X, Y, and Z are real numbers. And you can, you're used to visualizing R2 as the plane, where you just graph your X and Y points. So if you have 3, 2, you think of that as the point 3, 2 there. In R3, it's a little bit different. If you haven't seen it before, this is a picture of usually the way we are going to visualize these things. So here you can see we have 3 dimensions here with 3 planes, or sorry, three axes that are each perpendicular to each of the other 2. And you can maybe look around at different angles there to rotate it. And this red, green, and blue things here represent what your X, Y, and Z coordinates mean. So if you leave Z, the blue one here, 0, that means you're just staying on the X, Y plane here, and you can move around here. This point is still showing up over here because it thinks I'm in a 2D graphics over here, but we'll just ignore it. So if you move the red one, if I change the X coordinate with leaving the other 2 constant, that moves you parallel to the x-axis, but perpendicular to the other 2 axes. Now, if I make x be 0, if I can, we can get to the y-axis here. So if I change the y coordinate, you move parallel to the y-axis, and then from there you can go up or down by changing the z coordinate here. And I chose red, green, and blue here, not just by coincidence, but also because a set of 3 numbers doesn't just have to represent a point in 3-dimensional space. It could also represent a color, because you could describe the red, blue, and green color coordinates of any point with those 3 numbers. So points can represent all kinds of different things, not just points in space, not just colors, but all kinds of things. And you saw the example in the online Rabinoff textbook with the flow in the traffic streets, where you could have an R4 point that would represent X, Y, W, and Z, the flows of these streets, and that's an R4 point, but it's not exactly, you could think of it as four-dimensional space, but you could also just think of it as four numbers that it's handy to represent as one thing. And what if you had a much bigger network, I meant to say, where you're talking about not just this one town square, but like the whole city? Then you might have 100 variables or something for the different blocks that you're interested in. Or if you have not just a simple chemical reaction of burning ethane, what if you're talking about some complicated protein reaction that happens in biology where you have lots of different elements involved? Then you could use a point to represent the different amounts, or the different amounts of the different things going into it. Okay, so but how can you visualize something like an R5 point? Well, an R5 point would be any point with 5 coordinates, and if you're going to try to draw it, you would need to take R3, but then get another 2 axes, an x4 axis and an x5 axis, that are perpendicular to these other 3 axes, but that isn't something you can really picture. So how do you picture it? Well, a way that works well for me is I like to think of it as a collection of 5 different number lines, kind of like how in this picture over here, you had these 3 different number lines to represent R3. But we can't draw the 5 different things all perpendicular to each other like this, so we'll have to settle for just the sliders. Now, if we say something like, a common kind of sentence that comes up in linear algebra is we might say something like B is in R5. And what that really means is that's just a shorthand way of saying that B is a point with 5 coordinates. Specifically real number coordinates. So maybe you're actually given those 5 coordinates. You could show B. If you wanted to graph B, it would have to look something like this. So maybe this is B. Maybe B, it looks like we got something like a 1, negative 3.2, 0, 0.3, and 2.8. Something like whatever those 5 numbers are. So that's a way you can represent a point, is like this. And this is actually kind of a handy way to think of multiple dimensional points later on when we're talking about more abstract vector spaces. We'll come back to this.